Hello, in this lecture we will find the area of the green triangle. In the drawing we have an equilateral triangle. ABC is triangle ABC is an equilateral triangle, and inside the equilateral triangle ABC we have triangle FDE, that is a right triangle. Angle FDE is a right angle, therefore triangle FDE is a right triangle, and we know that AF equals to BF, and BD equals to 2 units, and DC equals to 4 units, and we want to find out the area of the green triangle FDE. First of all, as you already know, all the angles of an equilateral triangle equals to 60 degrees, so angle BAC equals to 60 degrees, and also angle ABC equals to 60 degrees, and also angle BCA equals to 60 degrees. And also the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. Okay, AB equals to BC equals to AC. Okay, AB equals to BC equals to AC, but we know that BC equals to BD plus DC. Again, BC equals to BD plus DC, and BD equals to 2 units and DC equals to 4 units. So actually BC will be equal to BD, that is 2 units, plus DC, that is 4 units. So BC equals to 6 units. So actually all the sides of this equilateral triangle equals to 6 units, and if we define line segment AF as X, then AF that equals to BF, so BF also will be defined as X, and actually AB, side AB equals to AF plus BF. So actually side AB of the equilateral triangle will be equal to AF, that is X, plus BF, that is also X. So actually side AB equals to 2x for one side, but also we found that also side AB equals to 6 units. So we have this equality, it states that AB equals to 2x, that equals to 6, so we actually can deduce from this equality that 2x equals to 6 units. Okay, so we can write down that 2x equals to 6 units, and if we divide this equality by 2, we will get that x equals to 3 units. Okay, x equals to 3 units, so actually AF that equals to x is 3 units, so AF equals to 3 units, and AF equals to BF, so BF also equals to 3 units. Okay, and we will use the law of cosines in order to find out the value of line segment FD. First of all, we will define FD as A, that is to say FD equals to A, and we will define DE as B, that is to say DE equals to B. So actually the sides of the green triangle FDE are A and B, and actually the area of the green right triangle will be equal to the base of the triangle, that is B, times the height, that is A, over 2. So the area of the green triangle will be equal to B times A over 2. Okay, so the only thing that we have to find in order to find out the area of the green triangle is the values of A and B. Okay, so in order to find out the value of A, that is FD, we will implement the law of cosines. So what is the law of cosines? Actually, the law of cosines apply to any triangle. So in any triangle, that is to say, we can use the law of cosines in any triangle. So if we have triangle if this side, if this side of the right triangle is A, this side equal to B in length, and this side is C in length, and this angle is theta, then according to the law of cosines, the following relationship exists between the sides of this right triangle and angle theta. Okay, according to the law of cosines, c squared equals to a squared plus b squared minus 2 times ab times cosinus theta. And it is true in any triangle, so c squared equals to a squared plus b squared minus 2 times a times b times cosinus theta. Okay, so we actually can implement the law of cosines in the small triangle FBD. Okay, so in triangle FBD, if we implement the law of cosines, then according to the law of cosines in triangle FBD, FD squared equals to FB squared plus BD squared minus 2 times BF or FB times BD times cosinus 60 degrees. Okay, so we actually implemented the law of cosines in the small triangle FBD, and according to the law of cosines in the small triangle FBD, FD squared equals to FB squared plus DB squared minus 2 times FB times BD times cosinus 60 degrees. Again, FD squared equals to FB squared plus BD squared minus 2 times FB times BD times cosinus 60 degrees. Okay, but what is FD? FD actually equals to A, so we can write that FD squared equals to A squared, that equals to FB squared. FB equals to 3 units, so FB squared will be equal to 3 squared, that is 9, plus BD squared. BD equals to 2 units, so BD squared is 2 squared, 2 squared is 4, minus 2 times FB is 3 units, times BD is 2 units, times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that a square equals to 9 plus 4 minus 2 times 3 times 2 over 2. We have 2 in the numerator of this expression and 2 in the denominator, so we can cancel 2. So what left from this expression after we cancelled 2 is actually a square equals to 9 plus 3, 9 plus 3 is 13, minus 2 times 3. 2 times 3 is 6, so it is minus 6. So a square equals to 13 minus 6. 13 minus 6 is 7, so we got that a square equals to 7. A square equals to 7, and we will take a root out of this equality and we will get that the value of a is root 7 units. A equals to root 7 units. Okay, so we can write here that a equals to root 7 units. Okay. In the next step, we will define angle BFD. This angle is theta. And we will define angle BDF as alpha. That is to say, angle BDF equals to alpha. And we will define angle EDC as gamma. And we will define angle DEC as beta. Okay, and we will use a new law, the law of sines, in order to find out the value of sinus theta. What is the law of sines? The law of sines applies to any triangle. That is to say, you can use the law of sines in any triangle. So I'll write down that in any triangle can the law of sines apply to any triangle. So in any triangle if we have triangle so if the length of this side of the right triangle is A, the length of this side of the right triangle is B, the length of this side of the triangle is C, this angle of the right triangle is alpha, this angle of the right triangle is beta, and this angle of the right triangle is gamma. Then, according to the law of sines, the following relationship exists between the sides of the triangle to the angles of the right triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Again, in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, so we actually can implement the law of sines in triangle FBD, the small triangle FBD, in order to find out the value of sinus theta. According to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Again, FD over sinus 60 degrees equals to BD over sinus theta. Okay, according to the law of sines, the implementation of the law of sines in triangle FBD is FD over sinus 60 degrees equals to BD over sinus theta. Okay, FD over sinus 60 degrees equals to BD over sinus theta. What is the value of FD? FD equals to A, and we found out that A equals to root 7 units, so FD is root 7 units. And what is the value of sinus 60 degrees? The value of sinus 60 degrees is root 3 over 2. Okay? And the value of BD is 2 units. BD equals to 2 units. It is given us in the question. And sinus theta is the value that we want to find out. And we will find out the value of sinus theta according to the equality that we created according to the law of sines. Okay, so in total we got that root 7 over root 3 over 2 equals to 2 over sinus theta. So we will move 2 to the numerator and we will move root 3 to the denominator and we will get that 2 times root 7 over root 3 equals to 2 over sinus theta. Okay? So times root 7 over root 3 equals to 2 over sinus theta. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. And what left after we cancel 2 in this equality is 1 over root 7 over root 3 equals to 1 over sinus theta. Okay, so after we cancel 2, we have root 7 over root 3 equals to 1 over sinus theta. In the next step, we will multiply this equality by sinus theta. And we will get that root 7 over root 3 times sinus theta equals to 1. Okay. After we multiply this equality by sinus theta, we got that root 7 over root 3 times sinus theta equals to 1. In the next step, we will multiply this equality by root 3. And we will get that root 7 equals to the root of 3 times 1 we have actually sinus theta times root 7 equals to root 3. So in this equality we will divide this equality by root 7 in order to find out the value of sinus theta. And we will get that the value of sinus theta equals to the root of 3 over root 7. Okay, we found out that the value of sinus theta is root 3 over root 7. In the next step, we will find the value of cosinus theta, and we will use the first trigonometric identity in order to find out the value of cosinus theta. The first trigonometric identity states that sinus theta squared plus cosinus theta squared equals to 1. So actually that is the first trigonometric identity that we use in order to find out the value of cosinus theta. Okay, we will subtract sinus theta squared from this trigonometric identity, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, we subtracted sinus theta squared from this identity, and we got that cosinus theta squared equals to 1 minus sinus theta squared. In the next step, we will take out a root of this equality, and we will get that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, so we actually found out the value of cosinus theta. Cosinus theta equals to the root of 1 minus sinus theta squared. But we have already found out that the value of sinus theta is root 3 over root 7. Okay, so we can write here that the value of sinus theta is root 3 over root 7. Okay. But if the value of sinus theta is root 3 over root 7, then the value of sinus theta squared will be 3 over 7. Again, if the value of sinus theta is root 3 over root 7, then the value of sinus theta squared will be 3 over 7. Okay, so we actually can substitute sinus theta squared on this equality by 3 over 7. Again, we can substitute sinus theta squared for this equality by 3 over 7, because sinus theta squared equals to 3 over 7. So we will get that cosinus theta equals to the root of 1 minus sinus theta squared, and we substituted sinus theta squared by 3 over 7. So we get that the following equality, that cosinus theta equals to the root of 1 minus 3 over 7. One minus 3 over 7 equals to 4 over 7. So I write it down. In total we got that cosinus theta equals to the root of 4 over 7. Okay, cosinus theta equals to the root of 4 over 7. But the root of 4 equals to 2, so I'll write it down that cosinus theta equals to 2 over root 7. So we found out that the value of cosinus theta equals to 2 over root 7. And we have already found out that the value of sinus theta is root 3 over root 7 Okay, so we actually found out the values of cosinus theta and sinus theta. Okay. In the next step, we will create 4 equations. The first equation states that the sum of the angles in triangle FBD equals to 180 degrees. Again, the first equation states that the sum of the angles in this small triangle FBD equals to 180 degrees. What is the sum of the angles in triangle FBD? It is actually 60 degrees plus alpha plus theta, and the sum of the angles in triangle FBD equals to 180 degrees. Okay, so actually this is our first equation that states that the sum of the angles in triangle FBD equals to 180 degrees. And our second equation will be in relation to triangle DC. We can say the same thing, that the sum of the angles in triangle DC equals to 180 degrees. Okay, our second equation states that the sum of the angles in triangle DC, this triangle, equals to 180 degrees. What are the angles in triangle DC? It is actually 60 degrees. The angles in triangle DC is 60 degrees plus gamma plus beta, all sum of these angles equals to 180 degrees. So equation number 1 states that the sum of the angles in triangle DC equals to 180 degrees. Okay, 60 degrees plus gamma plus beta equals to 180 degrees. In the next step, we will add together equation number 1 to equation number 2, and we will get equation number 3. So =60 degrees plus 60 degrees equals to 180 degrees. And we have here alpha plus theta, so I write it down. Alpha plus theta plus gamma plus beta. Okay, so we actually add equation number 1 to equation number 2. Okay, so this is actually the addition of equation number 1 to equation number 2 of this side of the equation, and in the other of the equations, number 1 and equation number 2, we have 180 degrees plus 180 degrees. It equals to 360 degrees. Okay. So equation number 3 created by addition of equation number 1 to equation number 2. So here we can subtract from equation number 3 120 degrees. Okay, after we subtract 120 degrees from equation number 3, we will get that alpha plus theta plus gamma plus beta equals to 360 degrees minus 120 degrees is 240 degrees. Okay, so according to equation number 3, alpha plus theta plus gamma plus beta equals to 240 degrees, and we will create equation number 4 that states that the sum of the angles in the upper side of a straight line at certain points equals to 180 degrees. That is to say, at point P, the sum of the angles at point D, the sum of the angles in the upper side of the straight line BC, the sum of the angles equals to 180 degrees, or alpha plus 90 degrees plus gamma equals to 180 degrees. Again, the sum of the angles at a certain point at the upper side of a straight line or line segments equals to 180 degrees. Alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so if we focus on at point D, the sum of the angles in the upper side of line segment BC equals to 180 degrees, or alpha plus 90 degrees plus gamma equals to 180 degrees. If we focus on at point D in relation to line segment BC, the sum of the angles on the upper side of line segment BC equals to 180 degrees, that is to say alpha plus 90 degrees plus gamma equals to 180 degrees. Here we can subtract 90 degrees for equation number 3. For equation number 4, again we will subtract 90 degrees from equation number 4, this equation, and we will get that alpha plus gamma equals to 90 degrees. So we subtracted 90 degrees from equation number 4 from this equation, and we got that alpha plus gamma equals to 90 degrees. Okay, but we have alpha plus gamma in equation number 3 also. In equation number 3 we have alpha plus gamma, and because of the fact that alpha plus gamma equals to 90 degrees, we can substitute alpha plus gamma in equation number 3 by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, so we will substitute alpha plus gamma by 90 degrees in equation number 3, and we will get that (90 degrees) plus theta plus beta equals to 240 degrees. Again, we substituted alpha plus gamma from equation number 3 by 90 degrees, and we got that 90 degrees plus theta plus beta equals to 240 degrees. In the next step, we will subtract 90 degrees from equation number 3, and we will get that theta plus beta equals to 240 degrees minus 90 degrees equals to 150 degrees. Okay. Again, we subtracted 90 degrees from this equation number 3, and we got that theta plus beta equals to 150 degrees. Here we can subtract theta from this equality, and we will get that beta equals to 150 degrees minus theta. Okay, we subtracted theta from equation number 3, and we got that beta equals to 150 degrees minus theta. Okay, but if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay, if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay, so actually, in order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta is actually sinus alpha cosinus beta minus sinus beta cosinus alpha. So, according to the second trigonometric identity, the value of sinus alpha minus beta is sinus alpha cosinus beta minus sinus beta cosinus alpha. So, we use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. Okay, so we will get that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. again we used the second trigonometric identity in order to find out the value of sinus 150 degrees minus theta. Okay, but what is the value of sinus 150 degrees? One sinus of 150 degrees equals to 1 over 2, and we have already found out that cosinus theta equals to 2 over root 7 okay, minus sinus theta. We have already found out that the value of sinus theta is root 3 over root 7. So it is sinus theta times cosinus 150 degrees, and the value of cosinus 150 degrees is minus root 3 over root 2. So in total we got that 1 over 2 times 2 over root 7 minus root 3 over root 7 times root 3 over root 2, that is actually the value of sinus 150 degrees minus theta, that is equals to sinus beta. So here in this expression we have 2 in the numerator and 2 in the denominator, so we can cancel 2. And here we have minus times minus, minus times minus is plus, and we have root 3 times root 3, root 3 times root 3 is 3. So in total we will get that 1 over root 7 minus times minus is plus, and root 3 times root 3 is 3. So in total we got that 1 over root 7 plus 1 over root 7 times 3 over 2, that is the value of sinus beta. Okay, in the next step we will take out 1 over root 7 as a common factor of this expression. Okay, so the value of sinus beta will be equal to 1 over root 7. We took 1 over root 7 as we took out 1 over root 7 as a common factor of this expression, and inside the brackets we will have 1 plus 3 over 2. So total we got that sinus beta equals to 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is 2.5, or 2.5 also equals to 5 over 2, so I will write it down. So sinus beta equals to 1 over root 7 times 5 over 2. So we found out that the value of sinus beta is 5 over root 7 times 2. Okay. After we found out the value of sinus beta, we can find the value of dB t equals to b by implementation of the law of sines in the small triangle DEC. So in the small triangle DEC, according to the law of sines, dC over sinus beta equals to dE over sinus 60 degrees. Again, dC over sinus beta equals to dE over sinus 60 degrees. Okay, dC over sinus beta equals to dE over sinus 60 degrees. Again, in triangle DEC, this small triangle DEC, dC over sinus beta equals to dE over sinus 60 degrees according to the law of sines. Okay, dC over sinus beta equals to dE over sinus 60 degrees. What is the value of dC? dC equals to 4 units, and we have already found out the value of sinus beta. dE equals to B according to our definition. And the value of sinus 60 degrees is root 3 over 2. So in total we got that 4 over 5 over 2 times root 7 equals to p over root 3 over 2. So here we can move 2 times root 7 to the numerator and 5 to the denominator, and here we can move 2 to the numerator and root 3 to the denominator. Okay, so we will get that two times root 7 times 4 over 5 equals to 2b over root 3. Okay, after doing the simple arithmetic, we got that 2 times root 7 times 4 over 5 equals to 2b over root 3. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. So what left after we cancelled 2 is root 7 times 4 over 5 equals to b over root 3. Okay, so that is what is left after we cancelled 2. In the next step, we will multiply this equality by root 3 in order to get the value of b. So we multiplied this equality by root 3 in order to get the value of b, and we got that b equals to the root of 7 times root 3 times 4 over 5 units. But we have already found out that the value of a is root 7 units. Okay, we have already found out that the value of a is root 7 units. And what is the area of the green triangle? The area of the green triangle, as I've already mentioned, is the base of the triangle, that is b, times the height of the triangle, that is a, over 2. So you should remember that the height must create 90 degrees with the base b, and the height a indeed creates 90 degrees with the base b, because this angle is a right angle. So the area of the green triangle is b times a over 2. So I write it down that the area of the green triangle FDE equals to a times b over 2. Okay, and we know the value of a equals to root 7, b equals to this expression. So the area of the green triangle FDE equals to the root of 7 times root of 7 times root 3 times 4 over 5 over 2. Okay, so that is the area of the green triangle FDE. Here we have root 7 times root 7 is 7, and 4 over 2 is 2. So we can write down that the area of the green triangle FDE equals to 7 times root 3 over 2 times 2 over 5 . Okay, so the area of the green triangle FDE equals to 7 times root 3 times 2 over 5. 7 times 2 is 14, so I write it down. So the area of the green triangle FDE equals to 14 times root 3 over 5 square units . Again, the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, the area of the green triangle FDE equals to 4.85 square units. The area of this green triangle equals to 4.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle FDE, and the green triangle is also a right triangle, and the green triangle FDE is inside the big triangle ABC, and triangle ABC is an equilateral triangle, and as you already know, all the angles in an equilateral triangle equals to 60 degrees, so angle BAC equals to 60 degrees, angle ABC, this angle equals to 60 degrees, and angle BCA equals to 60 degrees, and also all the sides of an equilateral triangle are equal to each other, so AB equals to BC equals to AC, and we also know that AF equals to BF, it is given us in the question, and we know that BD equals to 2 units, DC equals to 4 units, and we also know that the green triangle is a right triangle, that is to say angle FDE equals to 90 degrees, and we want to find out the area of the green triangle FDE. Okay, so actually BC, side BC of triangle ABC equals to BD plus BC. Again, BC equals to BD plus DC, but BD equals to 2 units and DC equals to 4 units. So side BC of triangle ABC equals to BD, that is 2 units, plus DC, that is 4 units, or side BC equals to 2 plus 4, that is to say side BC of the equilateral triangle ABC equals to 6 units. So we can write down that AB equals to BC equals to AC equals to 6 units. Okay, so from one side we know that AB equals to 6 units, and from the other side we know actually that AF equals to BF. It is given us in the question, and if we define AF as X, then BF that equals to EF also will be equal to X. So side AB of triangle ABC equals to AF plus BF, but AF equals to X and BF also equals to X. So side AB of triangle ABC equals to AF plus BF, that is to say side AB equals to X plus X, or side AB equals to 2X. Okay, so from one side AB equals to 2X, and from the other side AB also equals to 6X, so the AB equals to 6 units. Okay, all the sides of triangle ABC equals to 6 units. So from the other side AB also equals to 6 units. So we can derive this equality to 2x equals to 6 units from this equality, and 2x equals to 6, so we divided this equality by 2 and we got that x equals to 3 units. Okay, x equals to 3 units, that is to say AF equals to 3 units, and BF that equals to x also equals to 3 units. Okay, in the next step we defined FD as A, that is to say FD equals to A, and we defined DE as B, that is to say DE equals to B, and we found the value of FD by the law of cosines, by implementing the law of cosines in triangle FBD. What is the law of cosines? It applies to any triangle. In any triangle, C square equals to A square plus B square minus 2 times A times B times cosinus theta. Again, in any triangle, C square equals to A square plus B square times minus 2 times AB times cosinus theta. So we implemented the law of cosines in the small triangle FBD. In the small triangle FBD, according to the law of cosines, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, that is actually the implementation of the law of cosines in the small triangle FBD. Okay, but what is FD? FD equals to A, FB equals to 3 units, BD equals to 2 units, and we know that cosinus 60 degrees equals to 1 over 2, so the only missing variable is actually FD that equals to A. So we solved this simple equation and we found out that the value of A is root 7 units. Again, the value of A is root 7 units. Okay? Then we defined angle BFD as theta, angle BDF as alpha, angle EDC as gamma, and angle DEC as beta. And we found the value of sinus theta as angle according to the law of sines. What is the law of sines? The law of sines applies to any triangle. In any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So, we implemented the law of sines in triangle FBD according to the law of sines in triangle FBD. FD over sinus 60 degrees equals to BD over sinus theta. Again, in triangle FBD, according to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Okay? And actually, we've already found out that FD equals to root 7 units, sinus 60 degrees is root 3 over 2, and BD equals to 2 units. So the only missing variable is sinus theta. So we solved this simple equality and we got the value of sinus theta. We found out that sinus theta equals to the root 3 over root 7. In the next step, we found out the value of cosinus theta by implementing the first trigonometric identity. According to the first trigonometric identity, sinus theta squared plus cosinus theta squared equals to 1, and we subtracted sinus theta squared from this equality and we got that cosinus theta squared equals to 1 minus sinus theta squared. We took a root out of this equality and we got that cosinus theta equals to the root of 1 minus sinus theta squared. And we already found out that sinus theta equals to the root of 3 over root 7. So if sinus theta equals to the root of 3 over root 7, then sinus theta squared equals to 3 over 7. So we substituted sinus theta squared by 3 over 7 in this equality, and we got that cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. So we got that cosinus theta equals to 2 over root 7, while sinus theta equals to the root of 3 over root 7. Okay, so we got the values of cosinus theta and sinus theta, and then we created 4 equations. The first equation states that in triangle FBD, the sum of the angles are 180 degrees. Okay, so our first equation states that in triangle FBD, the small triangle, the sum of its angles equals to 180 degrees. Then we created the second equation that states that in the small triangle DEC, the sum of its angles are equal to 180 degrees. Okay, that is our first equation. our second equation that states that in triangle DEC, the sum of the angles are equal to 180 degrees. Then we added equation number 1 to equation number 2 and created equation number 3. Again, equation number 3 is the addition of equation number 1 to equation number 2. And then we created equation number 3 that states that in any point along in any point along a line, along a straight line, the sum of the angles in the upper side of a straight line equals to 180 degrees. So if we focus on point D, the sum of the angles in the straight line BC, the upper side of the straight line BC equals to 180 degrees. That is to say alpha plus 90 degrees plus gamma equals to 180 degrees. So that is our fourth equation. And from our fourth equation we got that alpha plus theta equals to 90 degrees. So we substituted alpha plus theta from the third equation by 90 degrees because alpha plus theta equals to 90 degrees. And we got that beta equals to 150 degrees minus theta. So if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Very simple equality. And in order to find out the value of sinus 150 degrees minus theta, we use the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. We use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta. Actually, sinus 150 degrees minus theta equals to sinus beta. So we found out by using this trigonometric identity that the value of sinus beta is 5 over root 7 times 2. Okay, after we found out the value of sinus beta, we used the law of sines in the small triangle DEC in order to find out the value of DE, that is B. According to the law of sines, in triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. Again, in the small triangle DEC, DC over sinus beta equals to DE over sinus 60 degrees. And we know that DC equals to 4 units. We have already found out the value of sinus beta. And we know that sinus 60 degrees equals to root 3 over 2. So the only missing variable is DE, that is B. We put all the data inside this equality and we found out that the value of B is root 7 times root 3 times 4 over 5 units. And we have already found out the value of A equals to root 7 units. What is the area of any triangle or the area of the green triangle? The area of the green triangle equals to the base of the triangle, that is B, times the height to the base, that is A, over 2. So A times B over 2 is the area of the green triangle. The height must create 90 degrees with the base B, and here we can see that the height A creates 90 degrees with the base B because angle FDE is a right angle. So the height is indeed A. So the area of this green triangle equals to A times B over 2. And we already found we have already found out the value of A is root 7 and the value of B, so the only thing that's left is to put the values of A and B in the formula for the area of the green triangle, or substitute A by root 7 units and substitute B by the value of B. So we found out that the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Again, the area of the green triangle FDE equals to 4.85 square units. Okay, thank you very much.